Hi everyone, so in this video we're going to take another look at Coulomb's law, but in this case, instead of using the melting point of a compound as a proxy for the force of attraction, we're going to use the Mohs Hardness scale. So in this very nice diagram from the mineralogy textbook by Klein and Dutrow, the vertical axis here is increasing hardness on the Mohs Hardness scale. So the Coulombic force, again, that's K times Q1 and Q2. Q1 is the charge on one of the elementary particles, and then Q2 is the charge on the other particle. D is their distance of separation. That is squared, so it has a huge impact on the force. We're just going to focus on this top diagram, and it's a really neat diagram. So here we have a series of elements starting with beryllium up here at the top, and then magnesium, calcium, and barium and strontium down at the bottom. And they're all being bonded to oxygen. So we're looking at the oxides, beryllium oxide to barium oxide. So the oxygen atoms in these cases all have a 2- charge. These fellows all have a 2+ charge. The beryllium atom is very small. The barium atom is very large. And so the interatomic distance here is going to be much greater than the interatomic distance here. And so with a larger distance, we get a smaller force. But in this case, instead of comparing the melting points, this guy is being measured for its hardness. How easily can we scratch it? So if we have a piece of barium oxide, how easy would it be to just carve a groove into that material? And for barium oxide, its hardness looks like it's just above 3, which would be the value for calcite. So it would be very similar in hardness to calcite, whereas the very small beryllium atom with this very short distance between it and the oxygen atom has a much greater force and a much greater hardness, a hardness of about 9, which would be the value for corundum. So there's a huge difference in the hardness values. Beryllium oxide would be very, very difficult to scratch. In fact, it would only be easily scratched by diamond, where barium oxide could be scratched by all sorts of materials, like quartz or plagioclase feldspar or apatite. So again, we're using the Mohs Hardness scale, the ability to scratch something as a proxy for looking at the force of attraction. And this Mohs Hardness scale can be quantified against things like interatomic distance, when we're looking at the bonding distance between a cation and an